Okay, today we are going to be looking at solving quadratic equations. It's a bit of a longer note, so let's get right to it. When we want to find the maximum or minimum of a quadratic equation, we need to get the vertex. When we want to find any other particular point, we need to solve. The important thing to remember before we use any method for solving is that one side has to equal 0. If it doesn't, we will need to rearrange the equation to make it say 0 equals something or something equals 0. It doesn't matter which side of the equal sign you put your 0, but one of them needs to be 0. Okay, the profit function for a business can be modeled by the equation p to x equals negative 0.5x squared plus 8x minus 24. X is the quantity of the item that they're selling in thousands, and p to x is the profit in thousands of dollars. How many units must be sold to break even, make a profit of 2,000, and make a profit of 100,000. So we're going to do this 3 times. We'll do it once in the factoring section since we've been factoring quite a bit, and once, twice with the quadratic formula. Okay, so what does break even mean? So we'll do this one in purple. Break even means a profit of 0, right? This means a px equals 0. Okay. So that one's simple enough because the one side of the equal sign is already 0. So we just type in our equation. Okay, we don't want a negative leading coefficient, so this common factor, we're actually going to common factor out the 0.5, and what that does is it doubles everything else. So 8 will become 16, and 24 will become 48. Okay, so we're looking, it's now a simple factor, we're looking for the multiples of 48, that add to 16, and it's going to be 4 and 12, so we'll get x minus 4, x minus 12. All right, so that means our x values here are 4 and 12 because it's always the opposite of the bracket, and therefore either 4,000 or 12,000 items must be sold to break even. Okay, let's move on to the next one. So let's do the profit of 2,000. And remember, everything in this word problem are in thousands, so we're not actually going to put 2,000. We are going to put 2. Oops, sorry, that's a highlighter. 2 equals our equation. Okay, we need that left side to equal 0, so in order to get rid of that 2, we will subtract 2 from both sides. So we get negative 0.5x squared plus 8x minus 26. Okay, we're going to do the quadratic formula here. Our a value is negative 0.5, b is 8, c is negative 26. So if you remember back to grade 10, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. Okay, and then it's just a matter of filling it in. So negative b becomes negative 8. We have 8 squared minus 4 times negative 0.5 times negative 26. Okay, so x equals negative 8 plus or minus. So we have 64, and then negative 4 times negative 0.5 times negative 26 is negative 52. So 64 minus 52 divided by negative 1. Okay, so we'll have negative 8 plus or minus the root of 12 over negative 1. And we see that we have a negative 8 and a negative 1, so we could just cross that negative off and get rid of this. So it's just 8 plus the root of 12, or 8 minus the root of 12, which means that they will make 2,000 at either 11.46 thousand items, or 4.54 thousand items. Okay, so 11,460 items or 4,540 items. Okay, I'm not going to worry about a therefore statement just because of time. But let's do the last one. The last one wants them to make a profit of 100,000. So this time we're putting 100 in front of our equation. Okay, so we're going to subtract 100 from both sides. So 0 equals negative 0.5x squared plus 8x minus 124. Okay, quadratic formula again. A is negative 0.5, B is 8, C is negative 124. So we set it up the same as the last time. 8 squared minus 4 times negative 0.5 minus, multiplied by negative 124. Okay, if we do that, all the stuff inside the radical all at once on the calculator, we get 64 minus 248, which is a negative 184. And we can't do this. Can't root a negative. So what this means is the company will never reach $100,000 in profit using this model. Okay, a factory is to be built on a lot that measures 80 by 60. So switch to green here. I'm going to draw a rectangular lot, 80 by 60. Okay, so we have 60 meters, 80 meters. A lawn of uniform width. So a reminder, uniform width means the same width all the way around, equal to the area of the factory, must surround it. Okay, how wide is the strip of lawn and what are the dimensions of the factory? Okay, so we're going to put the factory inside the yard. And we know that each side of the lawn is worth X. Okay, so when we're working with the factory, the length of the factory will be the 80 from the yard, subtract the 2 X's if you're going left to right. So this will be 80 minus 2X. And same with the width will be the 60 from the yard, subtract the 2 X's. So 60 minus 2X. Okay, other information that we know here is that the area of the lawn is equal to the area of the factory. Okay, the area of everything, so the lawn plus the factory, so the whole yard is 80 by 60, which is 4,800 square meters. And since both parts have to be the same, we just divide that by 2. So the area of the lawn is 2,400 meters squared, and the area of the factory is also 2,400 meters squared. Okay, so now that we know that the area of the factory is 2,400 meters squared, and we know that the area is found by length times width, so we have 60 take away 2x multiplied by 80 take away 2x. We can expand this and solve. So if we expand the 60 minus 2x times 80 minus 2x, we get 4,800 minus 280x plus 4x squared. Okay, we want to solve, so we have to subtract the 2,400 from both sides. So 0 equals 2,400 minus 280x plus 4x squared. Okay, and then I'm going to just write this, just for simplicity, write it in the correct order that we're used to working with. Okay, so we always try to common factor when we have a number, a leading coefficient bigger than 1, so let's divide everything by 4. Plus 600, okay. It's simple factoring, but it's not very nice. We need all the multiples of 600 that add to 70. Luckily, it's one of the first ones you think of, so we get x minus 10, x minus 60, because 10 times 60 is 600, 10 plus 60 is 70, so that means the widths can be 10 meters or 60 meters. However, if we look back to our drawing, if each x was 60, then the factory would have a width of 0 and the yard would have a width of 120, which is too big. So right away we can see that it's clearly not going to be 60. Therefore, x is 10. So each strip of lawn is 10 meters. Okay, that answers one of the questions. The other question was, what are the dimensions? Okay, so for the dimensions of the factory, the length was 80 minus 2x's. Well, now we know that x is 10 and 80 minus 20 is 60 meters. And the width was 60 minus 2x's, which is 60 minus 20. So the width is 40 meters. Okay, last one. A water balloon is catapulted into the air from the top of a building. The height in meters of the balloon after t seconds is h to t equals negative 5t squared plus 30t plus 10. What are the domain and range? So we need to remember for domain, we will be working with x values, so that will be the x-intercepts. And for range, you'll be working with y values, so that's the vertex. Okay, so let's find the vertex first. It's in standard form. It's pretty nice to work with. So we have negative b over 2a, so that means negative 30 over 2 times negative 5, which is negative 10. That's 3, so it reaches the max height at 3 seconds. Then we plug that 3 into the equation. to get our maximum height, and it works out to be 55 meters. So the vertex is 355. Okay, and since we've already done quadratic formula, I'm going to put this information into vertex form and show you how to find the x-intercepts from there. Okay, so vertex form, so we have h to t equals, so our a value does not change, t minus 3, so the vertex occurs at 3 seconds and has a maximum of 55. Okay, so we want to isolate t. So we're going to subtract 55. So we have negative 55 equals negative 5 times t minus 3 squared. We will divide by negative 5 to get rid of that. So 11 equals t minus 3 squared. Get rid of the squared, we're going to square root. So plus or minus the square root of 11 is t minus 3. And finally we add 3 and add 3. So t is 3 plus the square root of 11, or 3 minus the square root of 11. And when you work those out on a calculator, you get 6.31, or negative 0.31. Well, we're not going to go back in time, so it's not going to be this. So that means 6.31 is the only x-intercept we care about. Okay. So domain and range. So domain will be our trusty XER, but it has a limitation because it should be TER. Working with time here. It can be between 0 and we found 6.31 seconds. The range is height, and we found that the height can be between 0 on the ground and the maximum of 55. Great. Finally, let's go green. When will the balloon reach a height of 30? Okay, so that's saying it wants a height of 30, and then we put in our formula. We subtract 30 from both sides. Gives us our 0. So we have negative 5t squared plus 30t minus 20. Okay, we can common factor out negative 5, but we're going to come up with values that we can't factor, so we're going to use, again, quadratic formula. Just do it quickly here. So t equals negative 30 plus or minus 30 squared minus 4 times negative 5 times negative 20. And on the bottom we have negative 10. Okay, doing all that radical stuff all at once, we get 900 minus 400, so it'll be 500. I'm just going to go over here. So we have negative 30 plus the root of 500 over negative 10, or negative 30 minus the root of 500 over negative 10, which gives us 5.236 and 0.764. So those are the times that the balloon reaches 30 meters.